Is my screen visible now? Is it on the slideshow mode?
Yes.
Okay. Yeah. So today we are talking about life cycle assessment, and particularly I'll be talking from the perspective of built environments towards end. But in the beginning, I would be focusing more on introducing life cycle assessment to you, because many a time what happens is we just think that okay, LCA is a famous tool, let's apply it for buildings. But let's first understand what is this whole fuss about life cycle assessment, where it came from, why we need to consider it from the built environment perspective, how we can use it. So all of that a bit. So it will be kind of an overview and an introduction of LCA, as well as I'll give you some examples from my personal experience with LCA in the built environment. But before beginning, I would also just like to take you through my journey on why I would like to talk about this topic, or how I came about in this whole field of sustainability assessment. So I did my BTech in civil engineering from Kerala, and then I did my master's in construction technology and management from IIT Madras. So it is during this time that I actually started thinking about the domain of sustainability as a whole. So I started working on an area called lean construction. So if you're civil engineers, you must have heard this term. And lean is all about reducing waste, optimizing processes, and all that. So I was at that point in time working how we can actually use a method of construction, or a methodology, or a philosophy like lean, and achieve sustainability in construction sites. So that is where my journey began. And then I worked in the construction industry. I worked with L&T for about 5 years. And then I understood the whole scenario on how the industry works. And so in these times, sustainability was not a big concern. And even today, it's mostly cost, quality, time is that would more the focus is on. But then I went and I was working as an assistant professor in NMIMS, and from there I joined IIT Bombay. It is during my IIT Bombay PhD research that I actually stepped into this whole domain of sustainability assessment for the building sector. And as Brijesh introduced, I worked mostly in the modeling and simulation aspect. LCA was again an important component of my study, the philosophy of LCA as such. And then I joined TERI, which is the Energy and Resources Institute, which is again an institute closely working towards sustainability and climate change. And I just joined IIT Delhi last week. So this whole journey of sustainability has been mostly from the perspective of the understanding of from what I got through my industry experience, and then the need of the hour on why the industry should move towards sustainability, and why it should embrace tools such as LCA and other assessment tools as well. So now I'll formally begin the session. As I mentioned, the first section of this whole session, I would be focusing on uh, LCA from a very generic perspective. I just want all the participants to first understand what is this whole thing about LCA through some examples, in a very simple manner, and then we can talk about buildings, which is much more bigger. So you will understand how huge, how intensive it is to do an LCA. So before beginning, I would just like to know from the audience that if you could think about 5 things that you used from today morning till now, and if you can just simply rank them. And I'm not sure if the chat works. So if your chat works, if you can just simply list down 5 items that you've used today and rank them in terms of the impact that you feel it has on the environment from highest to lowest. So I'll just try and see if I can see the chats. I just want the participants to be a little more interactive. Uh, is the chats enabled, Brajesh?
Yes, chat is enabled and even participant can unmute themselves to speak.
Yeah. So for now I would just want you to just list down 5 items that you have used from today till this time, which you feel impacts the environment from highest to the lowest. Any 5 items. I'm sure you must have used more than 5 things today. The first thing we all wake up and probably take in our hand is our phone, right? So I just want you to rank it in terms of, 5 items. I want you to rank it in terms of your feeling that which is going to be the highest impactful uh, thing.
Yeah. So in the chat box, people are writing like
Yeah,
phone, laptops,
yeah,
car
I
for
can see that.
traveling to office, transport.
Okay, water heater, mobile, laptop, two-wheeler, gas stove, laptop, cell phone, geyser, vehicle, fans,
Breakfast. Hmm.
car, internet, laptop, mobile phone, washing machine, microwave. Okay. Okay.
Mhm.
So I think yeah. So if you think about it, what would have you made a rank the car as the most, what do you say, most impactful thing in terms of impact to the environment? Mostly we think that it's the transport because of course the whole fuss about pollution, the whole fuss about carbon emissions, or the greenhouse gas emissions that we talk about, right? So this is a general common perception that environmental impact means it is mostly emissions. It is only what you say, the impact because of greenhouse gas emissions. So this is something that LCA is beyond just greenhouse gas emissions. That is the first thing that I would want to put forward. It is not just about the impact that it has on climate change. It is the impact that it can have on any ecosystem for that matter, be it the terrestrial ecosystem, be it the aquatic ecosystem. So there are several environment impacts can be in different forms on the environment. So our understanding generally is that okay, we grade these things based on, we think that okay, this item emits something. A car emits some emissions is coming out of because of driving or because of the fuel that it is consumed. So this is a general perception, but we can't be sure that it is not the car. Probably it is your mobile phone that is being, it is more impactful, or it could be just your toothbrush because of the way it is produced. So we can't say for sure without quantifying or without understanding the numbers. So that is what LCA helps. LCA is not a magic tool. It is not a tool which suddenly solves all your problem. Life cycle assessment is a tool. It's a tool which helps you understand where your product stands in comparison to some other product or in terms of impacts. Now, what to do with that to reduce that impact, that you have to figure it out. So that's the first thing I would put forward before talking about the session. Now, if I ask, is LCA, why do we need it? Is it a voluntary tool or is it a compliance? Any answers? LCA, is it a voluntary or is it okay? It's a voluntary, right? Why do we need LCA? Okay, yes. So in today's time, when we talk about LCA, it is, yes, it is a voluntary, but it is not very far, maybe in some or the other form in terms of, let's say, reporting, or when it comes to a certain compliance that may be required, we might end up doing it as not just as a voluntary action, but as a compliance as well. And why it is needed? Because it gives us a clear picture on what is that impact across different dimensions of the environment because of making a product or using a product for that matter. So now going into, as I mentioned, the first few slides or sessions of part of this whole session would be mostly focused on general LCA, because understanding LCA is important before we get into the buildings as such. So LCA, it is actually a systematic analysis. This is a textbook definition of it, or systematic analysis of the potential environmental impacts of products and services during an entire life cycle. So ideally, life cycle assessment, when we say, we speak about from the material manufacturing phase till its end of life. What is the impact because of of a particular product, or because of a service, or the product could be as small as a safety pin, it could be as big as a ship or as big as a big tower, or it could be different services. So life cycle assessment is just a tool or a set of guidelines which help you quantify these impacts. So it helps you get some numbers for the impacts. And now it also brings us to the point that every product has a shadow. And when we say a shadow, shadow is something dark, right? So every product does involve some environmental impact. We cannot say that most of the products, while from production to use, they involve some or the other kind of influence on the environment or a pressure on the environment. Now, how dark is that impact? How big is that impact? Is what LCA helps us to find. And today, when we speak about what you say, only if we talk from the emission perspective, we talk about net zero buildings, we talk about net positive energy or net positive carbon buildings. What does all this mean? It doesn't mean that suddenly the building stopped whatever, the building just magically appeared there and there was no emission made. It is just that what impacts has been created because of the building, it has been offset by some other means, or we are probably using some means by which we can meet the energy requirements, or we are offsetting it by other means. So there are different perspectives to it, but there is definitely an impact, and LC is a tool which helps to understand impacts. And if we look at some historical perspective, so the whole concept of LCA actually started somewhere in 1969, and the interest of this actually came up mostly from the packaging industry. So, because at that time there was a lot of debate on the kind of packaging used for beverages, and for the transportation of beverages primarily. So if you see, there you will find a lot of studies which talk about packaging and beverage packaging, which bases it on LCA, a lot of LCA studies like that. And then gradually with time, we find a lot of databases have been developed which help to which facilitate the performance of LCA. Then we have a lot of so today we have a lot of databases available country wise. I'll talk about all of this in the later phases. But LCA is evolved and it is still evolving. So that's what at the point I wanted to bring. And it was not that suddenly LCA was developed for buildings. LCA came from a whole different background, and then slowly buildings, you find a lot of studies which do life cycle assessment, but it is not easy. I would put that first. So doing a whole life cycle assessment for buildings, it's not an easy task. So now, before talking about buildings, I would very simply take you through a very simple case study which describes LCA process as such in a very simple form, so that you have an understanding of LCA from a case perspective before I talk about the formal steps involved in doing LCA. So uh, this is a case of actually very commonly adopted case. You have a single use cup over here, and then you also have uh, just let me get a pointer here. Okay, so you have a single use cup, and then you have a multi-use cup. So this, just imagine a scenario, there is the program in a stadium happening, and you have two options here. One where you can use a single use cup, which is either a plastic cup or a paper cup, or it is a multi-use cup, which is a polycarbonate cup, which can be used multiple times. That is, after the a program, you can just wash it and reuse it. So this is a scenario here, a single-use cup which just used once and it's thrown. So what happens? So when you are considering the impacts for this single-use cup, you're considering cup manufacturing, you're considering the transportation of the cup from the production to the stadium, and finally cleaning of stadium, and then just you're just eliminating it through incineration. For this multi-use cup, which is made of polycarbonate material, you are again taking some
Yeah,
manufacturing some
so
cups, and then
just to
you
you
are
can quote, but actually finally will not go for this. This will be time based.
uh,
Can you
The
please
time base will be from that control room.
is
Ah, yes.
is
I'm
somebody
So
requesting
asking a
basically,
question?
you are
Yes.
not, because I understood as temperature sensors. So this is
can you
can be a
mute?
room sensor, default control, or not the.
Sorry
Yeah.
for the
No, no, it's okay. So, I hope my slides are moving, right, Brijesh?
Yes, it's moving.
Yeah, okay. Yeah, so then comes the multi-use cup where we are considering again the cup manufacturing, the transportation of the cup from the production site to the stadium. And then the transportation we need after the use in the stadium, we also need to wash it. So we might have to take this whole big, so we are talking about a stadium, a huge stadium and then from there we are taking these cups to wash it and then bringing back again using it. So multiple uses and then in the end at some point in the time again the cup becomes it becomes useless, right? You can't keep using it forever. There is a certain limit for that as well. So where this case study we talk about is primarily we are considering a cup which holds, so both the cups, whether it's a single use cup or a multi use cup, we are talking it from a perspective of, let's say, 300 ml use for one use or 300 ml use. And if it's a multiple use, we are considering the impact of 150 over here. That is 150 times it is being used again and again. That is what we are considering. The number of uses is 150. After that, we are assuming that the cups are we cannot be used again, because after 150 uses, we are assuming that. That is one case. Again, also we are also need to account that whenever we are transporting these cups to wash, there is a possibility that all these the cups might not be actually transported in the best condition. Sometimes we might end up losing, the number of uses might go below, or we cannot compare 150 uses, we might get lower because of the losses during the transportation. So considering this scenario, so the scenarios considered here is a paper cup which is used once, a polyethylene cup used once, a polycarbonate cup which is used 150 times. But in this scenario, we are not considering the transportation between the stadium and the washing facility. And then we are also considering a polycarbonate cup which is used 150 times, with we are considering 5% loss at every event, and we are considering a transportation of 50 kilometers. It has to go and then get washed and come back. So each time it is loaded, around 1,000 cups are loaded together and then it's cleaned and then it comes back. So these assumptions we are making of these scenarios is what we are comparing here. So in LCA, what we primarily do is, I will come to LCA step by step later, but from a case study perspective, first you have to understand. So in this particular case of cups, we are considering a cup of one use of 300 ml. That is our unit here. So now we are considering the paper cup, the polyethylene cup, and the polycarbonate cup here. And we are in LCA. What we try to do first is we try to understand what are the materials used for manufacturing of a particular cup of this scale, and because of this use or because of the manufacturing process, what is the emission to the air in terms of different gases. So you have benzol, you have methane, you have carbon monoxide, you have carbon dioxide, you have nitrogen oxide. So you have a lot of emissions because of manufacturing of this. So there are instruments available, there are methods by which we can actually quantify these emissions there. But it is again, we have to do it in the labs, we'll have to collect samples, we have to do it this, and then but somehow we can get this data that, okay, this is the emissions to the air and this is the emission that happens to the water. So because of the whole process of making all of this, there is some emissions to air, there is some emissions to water, there is some emissions to soil, and there is some resource extraction happening as well. So there are all of this data that we have to quantify if we are doing a proper LCA. So this particular study, they have done all of this, and finally they have come up with a particular what do you say, a representation of the impacts in terms of three indicators. So one indicator is human health, the other one is ecosystem quality, and then it is the resources, the impact on resources, the resources depletion basically. So here, if you see these graphs, so this is the paper cup and this is the plastic cup, and then you have the polycarbonate cup. Then you have the polycarbonate cup with the transportation losses. So here you can see that obviously the single-use plastic cup is definitely showing the highest impact. But if you see the polycarbonate cup, when we are not considering transportation, when we are not considering washing, only it shows a very low impact. But if we are considering transportation with the losses that can, so instead of 150 uses, if we end up getting lower number of uses, we'll end up purchasing more cups or using more cups for the same purpose. So there again, the impacts we can see are quite high. So this sort of comparison across three indicators. So here, when we say 100, we are comparing the polyethylene, the plastic cup, to have the highest impact. Compared to the plastic cup, what is the impact relative to the to other options or other scenarios we have considered? So this is what in LCA generally you will find. You must have come across a lot of such graphs which compares the particular impact of with a certain with different kinds of scenarios. Now, this is again an interesting representation over here, which is again in LCA, we do a lot of aggregation of scores. So I'll come to this also later. But we generally consider all the impacts and aggregate it into one score. So in this case, also, if you see, we can very clearly see that across all the stages. So the stages are basically manufacturing, transportation, stadium cleaning, transportation to washing, cup washing, and all of this is being included. So the basically the plastic cup has the maximum impact, especially the manufacturing process itself is quite huge impacting. Now, if you see the polycarbonate cup, the moment we account for losses, I mentioned losses again, it means that while transportation, instead of 150 uses, you're not getting that many uses because you lost few polycarbonate cups in the process. You ended up buying more of them. And then you are also having the transportation components. So it is again having quite a huge impact, even more than the paper cups. So as per this study. So sometimes what seems obvious is not what comes out in an LCA result, because the moment we consider it from an LCA life cycle perspective, we might think that okay, the product that they're using is actually less impactful. But unless we take the whole perspective, we will not get a clear picture as to which is the best alternative, or which is which alternative or we should go with. So that is something that we need to understand. That is the beauty of life cycle assessment, that once you are covering all the aspects, it gives you the numbers which based on which you can rely. Now here again, another thing that this study says that is that they have not considered the impact because of the use of detergents to wash the cups. So here it's just plainly the manufacturing, then just washing with some water, the transportation involved that is being included here. If the detergents are included, or if they are using a dishwasher kind of a setup, then that machine would be consuming some energy. If all of that is included, it could be possibly that these impacts might go higher. So this is something that we need to understand, that LCA gives us the holistic picture that which alternative is better from the perspective of a life cycle. So I just wanted to put forward this example before I talked about LCA in a very formal way, that so that you can relate it with an example. Now here, if you see, so for all the cups, the manufacturing stage accounts for most of the impacts, and then the transportation impacts is also there. If the moment you consider the losses in the polycarbonate cup, we can see that the impact is increasing because we are comparing it with the single-use paper cup. Then this again 50 kilometer, the distance that we have considered here. Now, as this varies, again the impacts would vary. And here, stadium cleaning is not considered as a very impact oriented activity over here. The end of life is also not considered much to impact in these all these four. So these are some of the limitations of this study. So the interpretation here, if we look from this, is that okay, single use PET or the plastic alternative is definitely not a good. But again, if you look from the results, okay, multi-use polycarbonate cup, if you're not considering transportation or no losses or no washing, then that's the best scenario. But we still can't make up our mind there, because the moment we include transportation, the moment we include washing, the impact is as high as that of a paper cup. So all of these things we need to consider. So there are a lot of assumptions, there are a lot of limitations that need to be accounted when we are doing an LCA, and we need to be very clear that this is there. It is not, it's not all black and white. So that's something that I would like to put forward. So the impact of soap again is not considered, because again the impact of soap could not just be on emissions. It could be on other aspects, such as the effect on water bodies, or the toxicity created on the water bodies because of the use of because of this whole washing process. So the impact could be huge, more than what we are actually seeing. So some of the key takeaways is that LCA gives you sort of a blueprint of the impacts of because, and it gives you an impact not just from an emission perspective, it gives you impact from wide perspective, from across different indicators. So that I will come to that again. So that is something that I would like to say. And again, what all is included in the LCA, based on that, your results can vary significantly. So if I just choose to ignore transportation, if I just choose to ignore washing, then I'm safe. I can say that polycarbonate cups are the best option. But is it right to ignore that? That's a question that we need to answer. So in terms of buildings also, when we are considering, should I really consider the impact while construction, or should I consider the impact of the building new space? I just need to worry about materials. Is that enough? These are the things that probably we need to understand while we are doing an LCA. Now I'll just again take you through again a fun example over here. So we all buy things from Amazon, right? So some scientist in Denmark somewhere, he just got curious that if we start using popcorns for packaging, how will it be? Will it be? Can we do an LCA and see whether it's a better alternative to this particular aspect? But again, let me put forward that okay, there is a all ethical issue associated, using a food item when there is already a lot of food crisis across the world, for packaging is not advised. But at the same time, this is again a scientist's curiosity that led him or her to go to a actual. So this actual study that was done to go to a farmer and explore and understand what is the impact if we use popcorns for packaging in place of what you say polystyrene chips. So this was the comparison that was made, and again, they again did a detailed analysis on what is the emission to the air because of all of these items. So if it is polystyrene, some impacts are there. If it's emission to water, there is some impacts. If you are extracting, there is some impact. And if you are using popcorn, then there is some impact. So from this numbers, when we look at these numbers like this, okay, there is the impact. If I'm using polystyrene in terms of carbon emissions, carbon dioxide emission is 5480, while it for popcorn it is 620. So clearly, of course, definitely popcorn is a better alternative. So this is what these results show you, right? And there is nothing wrong in these results. These results are very correct. But there is another big issue associated with the use of popcorn. So popcorn is around 4.6 times heavier than polystyrene. Now we are looking at what is the function of this whole thing. We want to package it. So we are looking from a volume perspective. We are not looking from a weight perspective. So here, if you look into this particular diagram, you can actually see the difference here. So if you are looking impact on a per kg basis, that is 1 kg of polystyrene packaging material and 1 kg of popcorn. If you're saying, okay, you can say that, okay, 1 kg to kg, if you compare, yes, polystyrene has definitely higher impacts. It is impacting creating a lot of issues. So popcorn is a better alternative here. But our aim here is to pack something. So the function here is to pack something. So if you look from a cubic meter perspective, you need more amount of popcorn if you want to pack the same amount of volume. So considering that perspective, you see, then you will end up getting that of course, for the packaging purpose from a per cubic meter perspective, you're ending up actually getting higher impact for popcorns here. So popcorn as a packaging material in this context, if you see, we'll see that okay, from a cubic meter perspective, this is definitely not the good option. So here the key takeaway again is that you can actually manipulate it in different ways. So people come out with certain results. Okay, this kg, 1 kg of this versus 1 kg of this. This is better alternative because it shows lower impact. But when you come from a utility perspective, are you considering kg to kg? So from a building perspective, are we talking about kgs or are we talking about square meters of the house that is being built? Or should we consider the whole house as a unit itself? In terms of utility, the house that can keep 4 people. So is that what we are trying to compare from apple to apple? Or so that is the key takeaway from this particular study on popcorns, which if you see kg to kg comparison, very clearly popcorn is definitely not that impactful. But if you look from a utility perspective of packaging, definitely it is not less impacting as the case goes. So this thing you will actually observe in most industries as well. When they come out with LCA reports, they come out with some way, they very smartly people come out with units which does not give us a clear picture from a utility perspective. So this is something that I would advise, that when we are doing an LCA study, we should be very careful as to what units we are using, how we are representing the results, over what time period we are representing. So I'll come to that again in the coming steps, in the steps of LCA. So now, LCA, the beauty of LCA is that it has all the frameworks and guidelines very nicely put forward in ISO standards, which makes it good because you have one standard method out there with all the steps put laid down, guidelines laid down, and all. But again, how do we do that? That is what I'm coming to. So, LCA has primarily four steps. The first step being goal and scope definition, then you have inventory analysis, and then you have impact assessment, and finally you interpret the results. So we will go through different stages one by one. uh, so goal and scope definition. So my first question is, again, why do we need a whole phase in LCA just to define the goal and scope? Is it really needed? Do we need to actually talk about the scope of the study or the goal of the study as a very important step in LCA? Yes, we do. The reason being, again, all the previous cases very clearly say, unless you define your scope, unless you define a unit, you can actually come out with wrong results. So that is why we need it. And of course, a problem well defined is half solved. So that is very clearly. So we need to define our scope, what you're going to consider for your study, because no LCA study, according to me, is wrong. And if you're doing some kind of an environmental analysis based on LCA, you are never wrong, but your goal and scope could be different from the person who has done a similar study somewhere else. That is the primary difference that comes. So defining this problem is important. So here, as per ISO 14044, they define it as that you need to be very clear why you're doing this LCA, what is the application of that, to whom these results are going to be communicated, or whether it's just going to be used for comparison between products, or it's to educate the public about the impacts. All of these should be very clearly put forward. And it should be very clear that we should not keep any ambiguities when it comes to reporting the goal and scope of the LCA. So why would we need to do the LCA? Primarily, we would want to understand the impact of an existing product, or we would want to compare it with some other alternatives. So 95% of the cases, we generally do an LCA when we want to compare something, when we want to compare building A with building B, or one building A built with a certain method on certain materials with a building B, or a material A with a material B. That is generally why we do LCA, mostly to compare alternatives. So it's mostly a comparison of between alternatives that we try to do and say that, okay, this alternative is better than this one. Then sometimes we would want to develop a new product and understand if the new product we developed is better than the previous version or the initial product that we proposed. And then LCA is very extensively used for policy analysis when governments want to test out if we are using a certain policy of, let's say, renewable energy, or certain policy of investing in a certain kind of product, whether that policy is better than the other one. So we can use LCA for that. And then for certain regulatory purposes also, LCA can be used. Now coming to goal examples. So how do we generally define a goal? So mostly we do it for assessing environmental impacts. So if we can say that the goal of a particular LCA is to assess the environmental impacts. We want to assess greenhouse gas emissions, water consumption, and resource depletion associated with production of 1 ton of steel in a manufacturing facility for over 1 year period. So this is what we are trying to do. We want 1 ton of steel, and over a period of manufacturing over 1 year is what we are considering. What is the LCA, or what is the environmental impact associated with that? Then we could use it to just compare two buildings using two different technologies, two different packaging materials, two different construction materials. We can just use it for product comparison. But what is the unit that you would use is very important. Then, as I mentioned, for policy understanding, people do use, LCA extensively. Now, today, when we talk about sustainability reporting, we find the use of LCA extensively. Many companies, come out with LCA results. Today, again, in circular economy assessment, also a lot of LCA studies are being done when we talk about, closing the loop. And then in product design too, we find design A, design B, design C, which is the best design option in terms of buildings or in terms of electronics, which is the best option. So then again, waste management strategies. We are also doing a project on plastics where we are trying to understand this strategies based from an LCA perspective. So in each of these examples, we are trying to understand why we are doing the LCA, what is the scope of the LCA, what are the boundaries of the study, what is the intended outcome, whether it's for comparison, whether it's for improvement, whether it's for policy, whether it's just for reporting or for other purposes. So the goal should be very clear. That is the first thing. Then in the scope definition. Now, in the scope definition, a very important parameter is what we call as the functional unit. What is the unit of comparison? That is very important. Another important parameter here is the system boundary. I'll come to all of these in detail. So we have a functional unit where we'll decide, okay, 1 unit of this versus 1 unit of this is what we are comparing. And it just cannot be just kg all the time. It depends on the utility. Like in the popcorn case we talked about, it could be the utility was packaging, so it should be volume. Then boundary in the sense that do you want to do a whole life cycle of a building, or you only want to do it for just the manufacturing phase up till the materials reach the site, or you want to include the construction phase also, you want to ignore the operation phase. You can do, but then it doesn't become a whole life cycle as such, but it still, we can define the system boundaries like that. There is nothing wrong there. Then again, the next step in the scope definition is something we decide on what is the impact assessment method we are going to choose. So whether we want to report the impact in terms of the impact on human health, do we want to report in terms of resources that have depleted? Do we want to just report the impact in terms of global warming potential? Do we just want to say that this is the impact on climate change because of product A and product B? So that is decided in the scope. So we define that, okay, life cycle impact assessment method, this is what we will do. Then we will also decide on what interpretations we are going to make, what are the data requirements, what are the assumptions, what are the limitations. All of these things we will be fixing up in the scope definition. So in the first phase of goal and scope, we will define how the whole study is going to be before we actually do the study. So in the same phase of goal and scope, as I mentioned, functional unit is very important. So it's actually the unit or the measure that defines, it's actually quantifies the performance of the product or the unit that which you will use to assess. So I'll give you some example. Like it could be like the functional unit. It could be if you're comparing some means of transport, the the amount of impact caused because of transporting one person over a distance of 1 kilometer using a bus or using a car. So that could be a functional unit. Now, this is very critical because now let's say take the example of shoes and sandals. Can we compare shoes and sandals as such? We technically both of them is used for what? We are using for walking, or its specific purpose is to protect our feet. But sometimes shoes as an additional function to also protect us from the weather, which the sandal does not generally do. So when we consider the function of shoes versus sandal, we cannot actually compare just like that because both have different functions. The shoe has an additional function, protection of weather. So this is again another. We have to choose our functional unit very clearly. Then when we talk about washing machines, so we can talk about one washing machine. I can compare a washing machine by Bosch versus a washing machine by Samsung. But is that the best comparison? Maybe the Samsung machine is of 9 kg load and the other one could be of 11 kg. Then again, I'm comparing wrong. Or I could just compare the number of clothes, let's say washing, the impact of washing 10 clothes in a Samsung machine versus a 10 clothes in a Bosch machine, or the impact of washing per wash for each wash in a Bosch machine and each wash in a Samsung machine. There would be a difference, right? The energy consumed for a particular wash in machines are also different. Again, or I could just consider a time unit. That is, I can consider, let's say, 20 minutes of time. What is the impact because of if I run it on a Bosch and if I run it on a Samsung? So these are just examples by which you have to define your functional unit rightly. So whether when you're comparing buildings, generally we go with a per square meter comparison, and this per square meter. But again, when we are considering, are we considering per square meter of the carpet area, or are we considering the whole building as a whole? Because for the same carpet area, I can have a taller house, which can use more materials. But maybe so there are, so what you are comparing from the product perspective is very important. It should be apple to apple. It cannot be apple to orange. Then when you're considering again milk bottle versus Tetra Pak, I can consider a bottle and a Tetra Pak if both their capacities are 1 liters. So then it still makes sense. So then again, different types of cups is again something that we decide. But again, all the cups, if you see all these three cups, they have different volumes. So you cannot the teacup which is washable carries probably lesser quantity or volume of product than the other cup, or in terms of volume. So there should be a proper comparison. So comparability is very important. And if that does not happen, so if you are comparing the impact because of an apple pie versus a strawberry pie, it could be a per kg comparison, or if I compare one pie to one pie, at least the shape or the size or something should be uniform there. So that kind of comparability is important, because otherwise we will get a wrong impression, just like we got in the case of the popcorn study, where the volume versus the kg study was different. Now, again, to bring you a more relatable example over here, let's say I'm talking about the shirt that we are using. So I have an option to buy one shirt which is of high quality material and use it for 5 years. Or I have an option to buy a low quality material shirt and just use it for 1 year and then keep purchasing 5 shirts for use for 5 years. So you must be understand. So here, if it's a high quality shirt, I would be using one shirt with a lifetime of 5 years, and if it's the other case, I would be using 5 shirts over a period of 5 shirts with a lifetime of 1 year for the same time period of 5 years. So my functional unit here, not one shirt versus one shirt. I'm not comparing a high quality shirt with just a low quality shirt. I'm comparing a shirt whose purpose is for protection from weather and providing me privacy for a period of 5 years. And if that is the shirt, then I would need high quality, I would just need one shirt. Low quality, I would need 5 shirts. So you must be understanding that there is a difference. So the impact because of a low quality shirt, one shirt might be actually low. But if you're using five of that across 5 years, then there is a difference. But a high quality shirt may be actually impacting more, but over the period of 5 years, it might be impacting less than compared to your low quality shirt. So here, I'm trying to say is that the number, the quantum, the unit that you're using for comparison should make sense. So here, if I'm taking 5 years, it makes sense. Okay, I'm comparing a high quality shirt which I'm using for 5 years versus a low quality shirt, which again I cannot use it for 5 years, so I need five of them. And here again, just a cost perspective is also given out here. If it's a the high quality shirt, I'm purchasing it for 1,500. The low quality shirt comes for 500, but I end up buying five of them. So this is something that we all end up doing, right? We buy cheap things, but then it doesn't last. So, and we actually end up spending more. So this is something in LCA. This functional unit is very important when we are comparing two products. So I'm reinforcing this again and again, because in buildings too we make these kind of mistakes. When we come to choice of materials, we say that okay, let's put an insulation on top of the building. But again, that insulation has to be, because we are putting insulation, the energy consumption of the building is improving. But every 5 years, you need to replace the insulation. Again, you are ending up putting every 5 years, you are taking the new material and then you are installing 5 or 10 or 20. Again, the maintenance, the amount of energy or and emissions impacts that you're causing because of producing this insulation again is again doubled. So this comparison very clearly in terms of functional unit is very important. Similarly, when we take the case of incandescent bulb and fluorescent bulbs, right? So if we are taking an incandescent bulb as a scenario one and a fluorescent bulb as a scenario two, the function of a bulb is what? To give light. So simply if we compare one bulb to another bulb, it doesn't make sense. We need to put some numbers to the functional unit. We are talking about the light, the unit of light being 800 lumens here. So 800 lumens for a period of 5,000 hours. So if we need this much light for a duration of 5,000 hours, we would want 5 incandescent bulbs, but a fluorescent bulb, one of them would give you that same unit that you want. So now comes down to the fact, okay, now for 5 bulbs of incandescent bulbs, you have to calculate the impacts and then you have to compare it with that of the fluorescent, one bulb of fluorescent bulb. So this kind of a functional unit definition is very important. Now, if we talk about painting a wall, very simple thing. So now I'm considering two different paints. So I have multiple painting options available. But when I'm defining the functional unit to see which is having lesser impact, I should be very clear what I am comparing. So here I'm comparing the amount of paint. So I have options, two paints, paint A and paint B. And I'm considering complete coverage of 1 meter square primed outdoor wall for 10 years in Germany. So here if you see, I'm considering what? I need complete coverage. That's the thing. 1 meter square is my unit over here. And it's an outdoor wall and I need the coverage to last for 10 years. And that is the place is, why is this place important? Because location is important in terms of the impact that the paint is going. It's an outdoor wall. So what is the weather there? How will it be, how many times it would have to be reapplied in that particular place? All of this is important. And in a uniform color of 99.9% opacity. So this again, this kind of a specificity is given in terms of functional unit here. So here, if I'm talking about a reference flow or how much amount of paint I would need. So if it is for 1 meter square, I would need paint A. I just need 0.67 liters. But I need to apply it twice and repaint every 2.5 years. I need to repaint it. So that is the case of paint A. And in case of paint B, it is I just need 0.15 liter of paint B, low content of water, and only needs one application, and it lasts for about 5 years until the repaint is required. So I'm comparing two paints. The quantity required for this particular functional unit is different for both the paints. So the duration is again different. You need to repaint it every 2.5 years. Here you need to repaint it every 5 years. Maybe we might end up that 0.67 liters might be less impacting if we were not considering all these aspects. If we just go by 1 liter of paint A versus 1 liter of paint B. Painting is the function, if that we consider. But that is not the function. We are looking at this kind of a specificity in the functional unit. Now, if we want to compare soap, two different types of soap. So if it's a Dove soap versus Lifebuoy soap. So I always believe that Lifebuoy, we never see it finishing. So it's like, it's that older soap which stays the longest. And if we are using a soap like Dove, we find that, okay, it just smells away. But if you see size wise and all, more or less, it's the same. But so we can't just compare one soap to one. We might have to consider the amount of soap required for, let's say, 50 baths. Or, these many, if we are comparing a hand wash versus the using a particular soap, how many times, how many hand washes you are considering. So The functional unit, again and again, bringing back to the point, it's the one very important step in the goal and scope definition of LCA, because this is where a lot of manipulation happens, unfortunately, but at the same time, the awareness is necessary that we comparing the right things. Now coming to again important aspect in the first phase, we are still in the first phase, which is goal and scope definition, which is again the system boundaries. So here, system boundaries, when we talk about system boundaries, we need to understand that LCA, doing a whole building LCA and all is quite challenging if we have to consider all the phases and all. So there are provisions by which we can actually consider certain systems only. We can ignore that, okay, we are not concerned about certain things. We are only concerned about certain things. We can do that. But before that, we generally consider a process flow diagram. So if it's a process that we are considering, we consider process one, process two, process three. We try and understand what is all the amount of extractions from the environment that we are doing, what is the input for that process, and because of doing this process, what is the emission to the environment. The emission could be to the water, it could be to the soil, it could be to the air. So all of these, across each unit process, we have to demarcate or understand this. So this is something that we said we need to understand process by process. We will go. Now let's talk about boundaries. Uh, Whoever that is, could you please mute yourself?
Someone is speaking. Can you mute?
Okay, so now we have to talk about boundaries. So as I mentioned, we have a lot of phases when we consider the life cycle of any product for that matter: extraction, material, production, assembly, then retail and use, and end of life. And if it's a building, also more or less it's a simple. We have extraction of materials, then the materials get processed, the products are made, then we bring it to the site. We build our product or build our building, and then we use it, and then there is an end of life. So generally there are certain terms in LCA which we talk about. Cradle to grave is what conventionally LCA is known to be. That is, we are talking from raw material extraction to the point the building gets demolished. So if we are doing a whole building life cycle, it simply means that we have to consider all the materials that we are going to use for that building. We have to consider the impact because of each and every material, each and every process that is being going to consume for to create that building, and then when it is used, what is the impact, all of that, and then finally when it is demolished, what is the impact. So that is what we call as a cradle to grave study. Then we also have something called, generally what we do for most of the products or most companies when they are manufacturing products, what they generally do is what we call as a cradle to gate process, where we consider only from raw material manufacturing till the point where the products are manufactured, and just till the point, till the factory gate, till it's transported and it's gone to the site, or it's being used by a user. Some consumer is buying your toothbrush is not your concern. You just are involved in what you say in quantifying the cradle to gate of manufacturing of that toothbrush or manufacturing of that soap. What happens to whether the transportation associated with the consumer coming and buying that product and using it, and then it goes to the grave. That process is not considered. So you can do a cradle to gate also. And sometimes in certain products such as plastics, especially the kind of studies that we generally see is mostly a gate to grave. We are not considered about the upstream or manufacturing of that. We just want to understand the waste management impacts. So we can do a gate to grave. Whatever you are doing, it is important to specify. But a whole building life cycle or a whole product life cycle assessment is when you are doing a cradle to grave. And in modern times, we are just not considered just about cradle to grave. We can also talk about cradle to cradle because we are talking a lot about circular economy. So we are talking when a building's demolished waste can actually be used for creating another building, or the possibility of recycling. So if that circular economy principles and all need to be applied, it's not cradle to grave anymore. It is cradle to gate. where we are actually modeling the process of recycling, modeling the process of disposal, and then how we can recover these materials and reuse it. So all of that also we are considering, we can consider. So, but we have to be very clear in defining the scope, the goal of the study, and then reporting the results with the proper functional unit. Else, we will end up with wrong results. So that is the first thing that I would say. So that is what we were talking about, the first phase. So this, there is altogether a phase for goal and scope definition, because the challenges, the errors can happen at this phase. And if this is very clear, then what you are doing further will not go wrong. So that is something that I would like to put forward. Now let's go to the next phase, which is called as the inventory analysis. Now this is the most data intensive, most critical phase if we look at it, because this is the phase where you actually need to understand how many materials you have been using to create this product, be it a building or be it a safety pin. What are the materials that we are using to produce this? And because of the use of these materials, the extraction of these materials, and the processes that are involved in creation of, be it a building or creation of a safety pin also, what is the emissions that is going to happen because of all the processes? What are the environmental impacts because of all of this? So in the inventory phase is the phase where you actually, so if you are trying to understand, do an LCA study which involves concrete. So concrete is made of cement aggregates, and then you will have to then go to the cement plant from where the cement has come, and then try and understand. So for the extraction of cement, what processes have happened. Then again, the process of clinkerization at the cement plants. What is the emission because of the cement? And then when the cement is brought to the concrete plant and it's mixed, what is the emission because of that? So if you're actually ground level doing an LCA, you have to go to each of these factories from where all each of these materials are being sourced, the transportation that is involved, how much fuel is consumed in bringing the 1 ton of cement to the concrete plant. All of this you have to sit and you have to calculate. You will have a big inventory list of, we'll have multiple Excel sheets with which quantifies all of this, and then on top of it, you should have data of how much is the impact across each of these greenhouse gases. So be it air, water, soil, all of this, you will have to have the data. And then you have inputs and you have outputs. This is, you will have a whole big bunch of inventory with you. Now, this is when we have to actually do, or you have to very religiously do a very specific LCA from a very factory perspective or from a concrete plant perspective, or even sometimes for research work, we might have to do this kind of immersive inventory process. But you must be understanding, I'll come to the point again. So now let's take the case of a bulb, light bulb. For creating this bulb, you have glass, tungsten, copper, steel, aluminum, so many materials being used to just create this bulb. And not just that, the bulb has to be transported, some packaging is involved in that. Then the bulb uses electricity, then the bulb is finally disposed. So you have a lot of stages for just this bulb. Now, if we are talking about the incandescent lamp example, we needed 5 bulbs of this, and we that 5 bulbs needs 200 grams of glass. Now, if you're talking only about glass, then for the input for this particular glass, you would need a lot of materials to create this glass. So you need 224 grams of crude oil, 1 gram of iron ore, 1,000 liters of water to create this 1 kg of glass. So now this data is there with us. Now you have to calculate it for 200 grams. So you would need a lot of data. This could be a very long list, a very, very long list, where you have to then understand for this 1 kg of glass, I would end up emitting how much amount of carbon dioxide, how much particle material I'm emitting, how much benzene, how much lead, how much nitrogen oxide, how much volatile organic components. All of this, if we have to experimentally identify from each factory outlet or each factory, the smoke that comes out, we have to do this analysis and then come out with these numbers. It's a big tedious process. That's why we have a lot of databases available. That's how all these LCA databases came up, which have this inventory data. So it sort of gives us a relief. Okay, we have some database to rely on. But again, they are all not perfect. Many of the databases were developed. Most of the databases today that we have are Swiss databases or European databases. Again, US databases are quite developed. For India, EcoInvent database is quite good. They are again refining well, bringing out the data for the Indian context. So many of the construction materials you will actually find good databases in the EcoInvent, which gives the Indian context. And when I say Indian context is very important, because the manufacturing of cement in Europe and the manufacturing of cement in India is different. So the impacts, the outputs, the inputs, all of it would vary. So we can't take a database of the European database and use it and say that, okay, this is the impact, because we will be ending up getting wrong results. So religiously, if we want to do a life cycle assessment, we actually need to create an inventory. We need to actually go measure all of these inputs and outputs, and we need to have, we can, and there are softwares. There are LCA softwares like SEMA Pro, Open LCA, which is an open software. Then you have one click LCA, which is very famous nowadays for construction materials. You have all of these which come with this life cycle inventory databases. You also have a provision where you can create a database by actual measurement from the factories. So that is also possible. So this inventory phase is all about data collection. You are actually capturing the entire process, capturing everything that is involved in the manufacturing or the creation of that product, and the impact because of that product in terms of certain gases. What are the emissions in terms of gases? Now, again, so then there are issues in LCA also. We will come across cases where certain impacts are quite negligible, or the certain impacts in terms of mass is very small, but the impact is highly toxic. So as an LCA practitioner, when you list down all of these impacts, you have an option where you can remove certain things that you don't want to consider and keep it. So there are cutoff criteria that you can actually specify. Uh, Please mute whoever it is. So as I was talking about EcoInvent, so EcoInvent is actually a collection of several databases, and you actually have, databases for construction materials, for agriculture, for playthings, transport. You have different subsections under all of these databases, and by far, EcoInvent I found it as quite extensive. But if you are doing an agricultural based study, you will have to use AgriBalance or some database like that. And it was developed in the West, so you would find most of the databases are tailor made to the West. But again, I'm not saying that we are very poor in databases. Now again, in current times, a lot of databases are being developed. EcoInvent itself has come up with good databases, and the values that they're proposing are quite authentic as well. So again, if you have to create a database, for, let's say for 1 kWh of solar versus wind or coal, you can actually create these databases also. You can actually go down to the depth, do all the analysis, and come out with this one value for 1 kWh electricity. But it's very data intensive process, as I had shown earlier. So as I said, so define the goal, we define the scope, we define the functional unit, then we do the inventory. So for if it's for a building, we collect all the materials that is being used for the building, and then we try and map against how much emission because of each product. All of that we can do in the inventory phase. But again, all of these inventory phases again just telling you there are certain set of inputs, some output in terms of some gases are there. What is the impact of these gases, or what are the impact of each of these emissions? What is the problem if some benzene or some lead is being released to the water? What is the exact issue associated with it? That comes in the phase of impact assessment. So there again, you have to decide on what methods you are going to use for life cycle impact assessment. Here again, the irony is that you have numerous methods of life cycle impact assessment, and it's again a LCA practitioner's choice to use which method, or it is mostly based on a popular opinion or what is more suited for a country. So mostly we find a recipe impact assessment method as a good method in the current times. But then there is again certain impact assessment methods, ILCD methods, which actually focus only on global warming. So here, all the impact, all the emissions, all the gases that are emitted because of a process is only reported in terms of global warming in certain impact assessment methods. But if we go with methods like a recipe, there they bring out different impact categories. So global warming would just become one impact category. That is the beauty of LCA. LCA is not just about global warming. It can also tell you, because of the bulb that you are producing, the impact on the ozone layer depletion is so much, or the impact on land use. So initially land use, when we say, it is basically the loss of biodiversity that happens. So initially there was a forest area, now it has changed. Then there is a depletion of natural resources. Then acidification again is another big problem. A lot of it creates a lot of environmental impacts if this process of acidification happens. Eutrophication, again because of release of pollutants to the water bodies, there is a very high significant algal growth that happens. So if this algal growth happens, it will end up, reducing the sunlight to the marine organisms that live under the water. And because of the reduction of sunlight and oxygen, because all this algal bloom has happened on the water bodies, the marine ecosystem is severely impacted. So because of your bulb production, what is the impact on this what is the eutrophication impact, loss on the marine ecosystem? Then photochemical ozone generation, people from Delhi would understand, that the smog that comes up, what is the impact because of certain product on that. Then human toxicity is again something that talks about the carcinogenic impact because of production of certain products. So lot of carcinogens are also emitted in the process of manufacturing of materials. So that carcinogens genic materials are then combined using various methods, and the impact category of human toxicity and ecotoxicity represents that toxicity because of these pollutants. So as I mentioned, you can, in the life cycle impact assessment phase, you can get a lot of impact categories like this. This list can go longer. You can have 20 more to this list if you're choosing a certain method, XYZ method. But if you're choosing certain methods like recipe, you will have certain fixed impact categories. And then just for the ease of a policy maker, there is also a process by which you can actually aggregate all of this and put it into a single score. So that is something that generally is done for ease. We represent most of the things as a single score value. So here again, impact 2002 plus is
So,
a yes,
Dr. Francis, sorry to interrupt you.
yeah.
We need to like wrap up this slide within 2-3 minutes so that we can open the floor for the question answers.
Yeah, I'll just try. I would need around 5 minutes, and I can stay longer if needed, but okay, I'll try. So there are different impact categories, and then because you have so many impact categories, sometimes it's very difficult to communicate whether all of these, because when you see so many impact categories, you just still can't decide whether should focus on ozone layer depletion, whether you should focus on human toxicity. So there is an easier way to do that, where all of these impacts are actually clubbed into three simple endpoint indicators in the form of human health, in the form of ecosystem quality, and in the form of climate change, or in the form of resources. So this is also something that is possible. There we have midpoint indicators, which gives more details. We can have endpoint indicators. So there are methods like recipe, there is impact 2002 plus. There are different methods that are prescribed by softwares or by the literature, which helps you do this. So as I mentioned, this is again ways by which different impact categories are clubbed into 3 or 4 endpoint indicators. Then this is again about the difference. So you again have numerous methods for impact assessment developed across the years. Recipe was developed by Netherlands, and most of their, the SEMA Pro software and all is from Netherlands. So this is again a well-developed method. Now coming to some examples from the built environment, I would just like to take you through some of my research. So here, as I mentioned, I worked on the concept of dynamic life cycle sustainability assessment, primarily because in LCA, the biggest flaw was LCA is pretty static and it's only focused on environmental aspect. So my research was on how we can, buildings are not static in nature, buildings change with time. So the energy consumption of buildings change, the material properties of buildings change, the surroundings of the buildings itself change, the technology that is used in the buildings would change. So all of this would create a lot of dynamic aspects. So if we do a conventional LCA for buildings, it is never right. We need to consider these dynamic aspects and how can we do this. So my research was primarily on developing this dynamic life cycle sustainability assessment framework. So for that, we did it in a housing project. So I'll just quickly go to the primary result that came out was that if we ignore the dynamic property of buildings, that buildings change over time, and if we don't consider that in our LCA analysis, we will end up computing impacts that are actually at least 12% lower than the actual scenario, which would be, so we would end up doing an overestimation or an underestimation of the impacts. So that was one part of the LCA study. Then LCA is again a tedious job, so there was some work that I had done with, in the interest of time, I'm just skipping this part. But we had to do a lot of LCA in the tune of around 2000 for 2000 building data. We had to do around 1 lakh simulations. So for that, we used a machine learning based study also. Now, this is an interesting study which I would just take 1 more minute to discuss, which we have been doing on building envelope materials, not just insulation materials, but in building envelope materials used in India and Australia. So this is an ongoing study. Some part of it is under publication. So here we were talking about Indian envelope systems primarily. So we use mostly conventionally brick, AAC blocks, bricks, concrete based, solid concrete blocks, and hollow concrete clay bricks. So this is what is recommended by the Ministry of Housing for the affordable housing segment. So this was what was taken. In the Australian scenario, if we consider, we find mostly the envelope systems to be very much insulation based and very much based on wood, timber, and metal based. So we were just interested in doing an LCA of these envelope systems to understand what is the trade-off if we are using a certain envelope for the building, and when the building is in operation phase, when what is the energy consumption. So sometimes certain materials are not having that much impact on the environment in the manufacturing phase, but when we come to the energy consumption, we find that because we used a material which is not highly impacting on the environment in the manufacturing phase, the energy consumption of the building went up. So a very simple example, if we see in terms of energy performance, the AAC wall systems for the Indian conditions showed very low energy consumption. And this is important because energy consumption we are considering over 50-year lifetime. And the manufacturing process maybe happens, it's a one-time thing. So here, if we look at the what AAC blocks in terms of impacts, it's somewhere in the middle. So it is having some amount of environmental impact, but in the long term, if we see its energy performance is pretty good. So we can go for these kind of materials. So the choice of materials can actually be very much influenced by the environmental impacts out of because of the material manufacturing and the performance of that material when it is used in the building. So I'll just wind up on that note that this kind of LCA helps you take better decisions. In the Australian case, when we looked at, we found that the cellulose insulation was actually very good in terms of environmental performance, but in terms of energy performance, the cellulose insulation was the least performing. So is it worth to go with cellulose insulation because it is having lower material impacts? This was a question that needs to be answered. So on that note, I will be happy to answer any questions that you have, or you can write to me to discuss if you want to have further discussions. So thank you, Brijesh. I think I'll just wind up here.
Thanks, Professor N, for this insightful session. And now we are opening the floor for the questions, and we are requesting participant to raise your hand if you have any question, and we will call your name to ask if you want to ask your question by yourself, or you can put your question in the chat box also, and we can read up that questions.
Yeah, so somebody is asking me about the software that is being used for LCA. So I'll just answer, I've just answered it in the chat. Now, let me again upfront tell you that a software is just a facilitator. Okay, a software like OpenLCA or SEMA Pro helps you create the systems required for a whole building LCA. In that, you will have certain databases in that which you can use, but they might not be very much exact representative of your actual scenario. So suppose if it's steel follows a global database, but in Indian context it would be different. So your software makes the job easier, but it is not making it perfect in any way. So you have to be, as an LCA practitioner, you must be aware what mistakes you make while using the software. Software makes the job of impact assessment and inventory and all of this easier. And it's a quick way to do comparisons. Yeah, I think Shreyas has a doubt.
Yeah, yeah.
Mm.
Can you hear me, ma'am?
Yeah, I can hear you.
Yeah, ma'am, actually, my question was like regarding this LCA. So, in the Indian context for the Indian projects, if we are working on for the LCA thing, so what kind of guidelines do we need to follow? Like, do we need to follow EN guidelines or any kind of I mean to ask, like, what kind of ISO guidelines we need to follow for the LCA process?
Yeah, so the ISO guidelines that are given are actually general for LCA in anywhere in the country. So, sorry, anywhere in the world. So they define the steps and all of that. But if you're doing an LCA from an Indian context, you should choose the right database. The databases which actually give you the Indian context. So if you take EcoInvent has a cement India value, which it gives. Or if it's bricks, fly ash bricks, it gives you an Indian value based on Indian conditions. So if you go to the databases, SimaPro and all, these softwares give you very clearly the assumptions that they have made in bringing that value of cement there. So
Okay.
databases you have to choose wisely. You can there is nothing wrong if you're taking a European database, but the point is again it is not representative what you're trying to analyze. So as
Yeah.
much as possible, whenever Indian data is available, you have to use that. But it is not every material is still not on that list. I would put that
Yeah,
disclaimer.
actually,
Yeah.
yeah, ma'am. Actually, I why I asked because I used in one of the projects through one click LCA, but there we have to adjust some factor for the energy mix and all.
Mm.
So that's why I like asked for the Indian context.
Yeah, so
So eco
energy mix
invent,
also,
yeah.
yeah, EcoInvent has five grids given in the energy mix context. So it has a it has a north, south, east, west, and the northeast grid given. For per kilowatt hour electricity, it gives you a value based on five different grids in the Indian context.
Okay.
Yeah.
Thank you, ma'am.
Then there is a question on EPDs. Yeah, so environmental product declaration. Now, this is again an interesting point where most of the time you would find LCA results. But unfortunately, Nina, you have a website where you get a lot of EPDs globally. But for Indian context, EPD is not something that is commonly made. So you don't find so many environmental product declarations all in one place. But I don't exactly recollect the website. But if you go to a certain website, you will get EPDs from different countries. And India doesn't have a very good EPD database because it generally doesn't have a good database to do LCA. So if you have to do EPDs, you need to have some kind of this. Then somebody is asking about energy consumed. Um, Impact of energy consumed during the life cycle of the building in terms of millijoule per kg or millijoule per cubic meter. Will the LCA be incomplete as emissions are not considered? So here again, so again a good question. See, again, as an LCA practitioner, you can choose whether you want to report something in terms of energy or whether you want to report something in terms of emissions or you want to report something in terms of terrestrial ecotoxicity. So one fun fact in the last study that I was showing you, what happened is that we ended up finding that for the Australian condition, global warming potential was not a very important indicator at all. It was not huge in terms of impact. For the Indian context, the global warming potential or carbon emission, carbon footprint, or impact on climate change because of an envelope material was way higher than from the Australian context. For them, it was terrestrial ecotoxicity, which was the highest indicator, which is again on the toxic impact on the terrestrial ecosystem. So you can choose any kind of method, or if you're doing it in millijoules per cubic meter, as long as you're comparing apple to apple, we can't say it is incomplete. You are reporting energy, you are reporting life cycle energy, you're not talking about emissions there. Emissions, you will have to report it separately, you will have to talk about emissions separately. But in the context that you're talking, if embodied energy or life cycle energy is what is more relevant, then talk about that. So that's what I would like to say. Any other questions if I missed?
No. Anyone else who want to ask any question?
amongst the comparison of many wall assemblies, what was the point of commonality for comparison? So here in this case, we actually considered a, a certain building of a certain area very specifically for a certain lifetime, which housed a certain amount of people. So that kind of a functional unit we had to put. We had to put a house to house comparison. We couldn't do a per square meter comparison there. We had to take a same area of house, a typical building, same design, because we were considering wall assemblies, which goes all around. So if we do just a square meter comparison in Australia, the roof height would be higher, lower, it would change. So we had to do a one house, complete house of certain this much area versus a complete house of this much area, and then do the LCA likewise.
Yeah, so if there is no further question, we can end this session.
Yeah.
So thank you, Professor Anne, for this insightful session. And also, I would like to thank all the participants who participated in this engaging webinar. And I would like to announce that if you have any more further question and queries, you can mail us on thebusinesscharter@gmail.com. You can find this email in your chat box. And also, like if your organization would like to join as a signatory in this decarbonization business charter, you can send us your interest on this email ID. So once again, I would like to thank all of you for this interesting webinar. Thanks.
Okay, thank you, Brajesh.
Okay, so we can end this meeting now. Thanks.
Yeah.
Thanks, Professor Ann.
Yeah.